Hello learners, welcome to the video. There is a great saying that you don't have to be great to start, but you have to start to be great. So let us start our today's session with this great quote and understand the concept of distance and displacement in this session. Basically, in everyday language, the words distance and displacement are used in the same sense. But in physics, these two words have different meanings. In today's video, let us understand the difference between these two terms. Now, let us start by taking a simple and interesting example. Suppose your name is Harry and you are having summer vacations and you are getting bored at home. So you decide to go for an outing to a mall. Suppose your house is at point A. As you were about to leave, your friend Ishan called you and asked you to take him along with you. You were so happy to listen this and you instantly said yes. Now suppose your friend's house, that is Ishan's house, is at point B and the distance of your friend's house from your house is 4 kilometers. Now you reach your friend's house and both of you now leave for the mall, which is 3 kilometers from the house, and finally you reach the mall, which is at point C. Now in the mall you meet your physics teacher and she says, "Wow, you both are enjoying. Okay, tell me, how far this mall is from your house?" The boy who started from point A, that is Harry, says that, "Ma'am, first I went to my friend's house, that is Ishan's house, which is 4 kilometers from my house, and we together came here in the mall, which is further 3 kilometers from this house. So total path covered is 4 kilometers plus 3 kilometers is equal to 7 kilometers. Along with this, Harry adds that, "Ma'am, basically, this mall is 5 kilometers from my house in the east direction if I come directly from my house to the mall." Now, after understanding this example, let us define the terms distance and displacement. The distance traveled by a body is the actual length of the path covered by a moving body, irrespective of the direction in which the body travels. The SI unit of distance is meter. Distance is a scalar quantity. Now let us discuss about the next term, that is displacement. When a body moves from one position to another, the shortest path between the initial position and final position of the body along with the direction is known as the displacement. That is, displacement of an object is equal to final position minus initial position of the object. The SI unit for displacement is meter. Displacement is a vector quantity. Now let us understand some interesting points about distance and displacement with the help of an example. Case 1. Suppose you are going from Delhi to Shimla on a trip with your friends by flight, and suppose flight is following a straight route between Delhi and Shimla. Now Shimla is about 350 kilometers from Delhi. Now if we ask about the distance and displacement between Delhi and Shimla, then your answer will be distance is 350 kilometers and displacement is also 350 kilometers. Case 2. Now, while returning, you decided to visit Chandigarh, which is about 100 kilometers from Shimla. Now, if we ask about the distance and displacement between Delhi and Chandigarh, then your answer will be distance is equal to 350 plus 100, that is 450 kilometers, and displacement is equal to 250 kilometers because now Delhi is the initial position and Chandigarh is the final position. Case 3. Again, if we take one more scenario in which you started your journey from Delhi and came back to Delhi. Now, if we ask you that what is the value of distance and displacement, then your answer will be distance is equal to 350 plus 350 is equal to 700 kilometers and displacement is equal to 0 because now the initial position and the final position is the same. From this example, we can conclude the following points. First, displacement can be greater or equal to distance, but displacement can never be greater than distance. Second, if a particle starts from a point and reaches the same point at the end of its journey, the displacement is 0. However, distance covered is not 0. So, from the above examples, we can make following comparison between distance and displacement. Displacement of an object may be 0, but the distance traveled of the object is never 0. Distance traveled by an object is either equal or greater than the magnitude of displacement of the object. To calculate distance, the direction is not considered. To calculate displacement, the direction is taken into consideration. Distance depends upon the path, that is, it changes according to the path taken. Displacement does not depend upon the path, and it only depends on the initial and the final positions of the body. Now, based on this video, let us try to find the answers of the following questions, and we will discuss their answers in the next video. Question first, under what conditions can a body travel a certain distance and yet its resultant displacement is 0? Question 2, an ant travels a distance of 8 centimeters from P to Q and then moves a distance of 6 centimeters at right angles to PQ. Find its resultant displacement. Question 3, is displacement a scalar or a vector quantity and why? In the next video, we will study about motion in a straight line. Bye for now.